Welcome to some notes on the graphs of sines and cosine functions. So far we have defined sine and cosine on the unit circle, right triangles, and a circle of any length. But originally we defined them on a unit circle. And we said that cosine with the x coordinates, and it is, sine is the y coordinates. Well, what we're going to do now, instead of making those two functions exist only in a circle or a triangle, we're going to actually let the angle that we are rotating off the positive x-axis actually be an input, like an x coordinate. So notice this is 0, pi over 2, pi, 3 pi over 2, 2 pi. And we are going to allow that to be a horizontal value. Like the angle that we're rotating is now just a horizontal number on the number line. And then the sine or the cosine will be the height. In this case, starting with sine, the y coordinates will be the height above or below the angle on the x-axis. So it's a little bit different to view it the way we've been doing it. We've been just looking either at x or y to get sine or cosine. But now we're going to look at what the graph looks like, how the pattern of these things look when we lay it out horizontally, the angles out horizontally. Alright, so I'm going to start off, let me get a thicker marker to make my points. I'm going to start off at an angle of 0 radians, which makes a sine. This is sine. A sine is the y coordinate of 0. So 0 radians produces 0 for sine. Alright, and in pi over 6, notice here's pi, and there's 1, 2, 3, 4, 5, 6 to get there. So this is pi over 6 right here. So at pi over 6, I've got 1/2. So at pi over 6, there's a half. Okay, now pi over 4 is not an actual tick mark on here. This is 1 pi over 6. This is 2 pi over 6, which will be pi over 3. That's the square root of 3 over 2. Square root of 3 over 2 is about 0.86, 0.87, somewhere between those two. So 0.866. So that would be a little bit higher than, this is 0.75, so 0.86, right around maybe there. Okay, and then at pi over 2, we would get 1. Now if I wanted to put pi over 4 on here, I could, and there's pi over 2, there's 0, so pi over 4 would be right in the middle of those two, about right there. That's the square root of 2 over 2. Alright, so the square root of 2 over 2 is about 0.71, 0.70, so that would be about right. There's again 0.75, so right around in there. Okay, all right, and then we're coming back. As we come back, we're going to hit all of these same points again at the same intervals apart, meaning this is pi over 2, this is pi over 6 more than that. So I'm going to hit that at 2 pi over 3. I'm going to hit the square root of 3 over 2 again. So I'm going to be at that same height once again. And then that's going to be 3 pi over 4 right there, right between pi over 2 and pi. So I would hit about right there, a little bit below the 0.75. Alright, and then again I'll be at 1/2 at 5 pi over 6, which is pi over 6 less than pi. So I'd be back at a half. Alright, and then when I get to pi, alright, that sine, the y coordinate is 0. So I'm back down to here. Alright, and now what happens to the y's after that? They dip down into the negatives. So the same thing's going to happen. At pi over 6 more than pi, which is 7 pi over 6, I'm going to be at negative a half. Alright, and then the same thing's going to happen. I'll be at negative 1 down here at 3 pi over 2. At 2 pi, I'll be back to 0. Alright, and then these intermediate points. This is 1 pi over 6 more, 2 pi over 6 more. I'll be at negative square root of 3 over 2, which is almost to the top, so that'll be almost to the bottom down here. And again, because of the symmetry, it'll be like that. Alright, and then halfway in between these two is that 5 pi over 4, and 5 pi over 4 will have the negative square root of 2, which is like negative 0.7, so a little bit less than the negative 3/4. And the same thing right here, about, and then right there. Alright, so we get this wave pattern called a sine wave. And if I connect those dots, that's filling in the gaps in between the special angles, you know, for these values between 1/2 and square root of 2 over 2, and between those two. So we're filling in all the possible y values that we could get between those, all the way around the circle. Okay, now I've made myself all the way around the circle, so that's what we call one period. So one period of the sine wave is 0 to 2 pi, so 2 pi units is a period, what it takes to kind of get back. And then that's going from 0 to 2 pi, but remember, we can just keep going over and over and over and over and over again, and we just get this wave repeated as many times as we want to. Okay, so there's again what we just made. There it is. If we just keep on going either clockwise, counterclockwise, and just moving beyond 0 to 2 pi. Alright, so this is what we just did. The last one. That's that one period, but just notice it just keeps repeating in either direction. Okay, so as a function, and this is a function, remember, if you remember from pre-calculus 1, this passes the vertical line test, right? As the x-coordinate being the angle, and the output, the height, being the y-coordinate of the unit circle. That will always pass the vertical line test, even though it was originally defined on a circle that didn't pass the vertical line test. When we treat the angle that we're rotating as a horizontal input, now this thing does pass the vertical line test everywhere. So it is a function. And because we can just keep cycling around and around and around forever, we get a domain of all real numbers. Okay, it just keeps going to the left and right as far as we want to. Okay, the range is -1 to +1. That's the smallest it can be is -1, the highest it can be is +1 for the y values. And again, that's because we're talking about the y coordinate here, and the y coordinate never gets higher than 1, and it never gets lower than -1, but we do hit every other y coordinate in between those two somewhere on the graph. Every single y coordinate is hit. So that's why we're seeing that range. The period's 2 pi because that's how long it takes to get back to where we started. That's also because that's one revolution around the unit circle. Alright, and then this is something, another little subtle property of it, the odd properties and this symmetry that we get about the origin. So again, what that means is if a point AB is on the graph of the sine function, if we went from that point through the origin and then came out the other side the exact same distance, we would hit another point on the graph, and the coordinates of that other point would be -a, -b. So when AB is on the graph of an odd function, -a, -b is on that graph as well. Okay, so that's a property of the sine function. This is saying the same thing, right? Negative, the input is the opposite of what it typically we see it. We usually just see it as an x. So the input's the opposite, and that results in the output being the opposite. So -x, -y, that's another way just to say what I was just saying. Alright, one of the big things that you're going to do in this section and the first part of your project for the semester is going to be variations of the sine or cosine functions, typically sine. You'll see why in just a little bit that we typically just use sine. But the way that we're going to do that, the big important thing is that if you take the period of these things and just cut it up by 4 with sine and or cosine, you will get all the key points that are on there. You'll get the intercepts and you'll get the max and min points. they're always going to be a quarter apart. So you go from an intercept to a max or min by moving up a quarter of a period, and then you make your way from a max or min to another intercept by moving up a quarter of a period. Okay, so the period's 2 pi, a quarter of that is pi over 2. So when we move up a quarter, we get from an intercept to a max. Move up a quarter, we go from a max to an intercept. Move up another quarter, we go from an intercept to a min, move up another quarter, and that'll always be the case. So if your period is altered, and it will be on some of the ones that we're going to see later, you can find out how far apart the intercepts and the max and mins are going to be by just slicing that period up divided by 4. Alright, that's going to be a very important part of what we do when we start altering these things and graphing these things by hand. Alright, now if I want to do the cosine, same thing as before. I'm going to use blue this time, and now we're doing the x coordinates from the unit circle. So the angle is still moving out horizontally now, and we're talking about x coordinates. So when the angle was 0 radians, the x coordinate was 1. So we're all the way up here at the top. Alright, but then all the other important points that we see are going to be the same. They're just in different locations. At pi over 6, the x coordinate was square root of 3 over 2. So that was the one that was up here. Alright, and then this was, remember, not the square root of 2 over 2. This was 2 pi over 6, which meant pi over 3. So the x coordinate is a half. Alright, and then at pi over 2, the x coordinate is 0. And then again, if you want to fill in the intermediate value right there, we get the square root of 2 over 2, which again, right underneath 3/4. Alright, and then after here, the x coordinates dip into the negative until they get down to -1 at 0. Or pi, I should say. So down here, pi will be at -1. And we'll make our way down the same way. So at 7 pi over 6, moving 1 beyond that, the x coordinate is negative square root of 3 over 2. Oh, I'm sorry, that's pi. Pi over 2. That's negative a half. And then we get to this one. It's going to be a little bit less than 3/4. And then we're going to be right up here. Alright, and then we bottom out right here, and the x coordinates start getting bigger again. It's going to have that symmetry just like it had for sine. Alright, and then we're going to make our way back. From here, we're at 3 pi over 2, we got back to 0 for x, and then we're going to make our way back up again. So 1/2, and then right here we're just below, and then we're up here, and then finally we're back to 1. So what we end up with here, you may look at it and say, well, that looks different than what we had for the sine curve, but it's just because we started at a high point, and from 0 to 2 pi we made it back to a high point. You got to remember that this thing is going to repeat over and over and over again. So let me like group it all and shrink it down a little bit, and then if I stick it right on the end of itself and then think about it from right here to right here, now it looks the same thing as that we saw just there. Okay, but because one of them is starting at its middle value, the what we call the midline, the median value, I guess I should say, and the other one is starting at its high point, they initially look a little bit different, but they're not. They're the same the same wave over and over and over. It's just, it's kind of like a shift, a horizontal shift. Alright, so there's the property of cosine. So again, it's got a period of 2 pi. It starts at a high point. It doesn't start at the what we call the midline here, the middle. It starts at a maximum, and it starts going down initially. Alright, but same thing as before. The domain's all real numbers because it's just the angles. So we can just keep going around the unit circle as many times as we want to in either direction. The range is still -1 to +1. Again, the same reason. The range here is the possible x coordinates, and every single x coordinate is hit between -1 and +1 at some point on this circle. The period's 2π, just like before, because of one revolution around the circle. Now this is an even function. If you remember even functions, that has y-axis symmetry. So you could fold the cosine function over itself at the y-axis and it would hit back on top of itself. And y-axis symmetry means that if AB is a point on the graph, then -a, b, -a positive b instead of -a negative b is a point on the graph. So the heights stay the same when the inputs, the x's, change signs. So positive x goes in, this y comes out. Negative x goes in, that same exact y comes out. And that's true no matter where we start. If this x goes in, that y comes out. If the opposite of that x goes in, that same y comes out. Okay, so it's always preserving the same y value that we saw before when the x value changes. Alright, and then just notice if we graph them both at the same time, we see the same pattern. It's just kind of like a shift, like a horizontal shift. And there's the shift. We shift by pi/2. Pi/2 is 90 degrees, and that should make sense because if I rotate 90 degrees, the y-axis becomes the x-axis and the x-axis becomes the y-axis. Okay, so that we see that shift in there. Right? Now it's a little bit more than that. It's like a shift this way and then it's like a flip to get the signs right, because you notice this is like shifting to the left. So the cosine is the sine function shifted to the left, pi/2 units. So there's the cosine, there's the sine function. If we shift it to the left, we would end up right on top of the sine function, of the cosine function. Okay, and then vice versa. And the same thing as before, when we want to do variations of cosine, we're just going to take the period, cut it up by 4, and use that to make our way from maxes and mins to intercepts. It's just that we start off, typically at a high point, and then if you remember back from pre-cal 1, when you multiply these things by a negative, like if I started off and I graphed the cosine of x, and then here I wrote the negative cosine of x. So when you multiply these things by a negative, remember I click zoom trig, which is option 7. Here's the cosine function. So again, it's going to touch up here at the top. And the negative cosine function, remember that just flips it over the axis. So the point I want you to see is that, let me turn off this graph. When you graph the negative cosine function, now when the angle is 0, it starts down here at the bottom. I kind of zoomed in a little bit, made the window a little bit different to be able to see this better. But there is the angle is 0. There's this is -2, -1, +1, +2. So when the angle is 0, we're starting down here at -1 instead of +1, and we're going up. Okay, so one of the things that we're going to do eventually is alter these things, and the sine always starts at 0 on its midline. The cosine typically starts up here at its high point, but just multiplying by a negative, we can get it to start at its low point. So depending on what the situation calls for, we can alter the sines and cosines and get them to behave the way we want to. All right. Likewise, I could start off with the sine function, and because it starts on its midline but starts increasing, that's fine if the value of whatever we have initially starts increasing. But if we need it to decrease initially, it needs to go down into the negative or something, we can make that start at 0 and start going down initially if we want to, just by putting a negative sign in there. So that's the most basic alterations we can do, but we can do a lot of different things with these trig functions, and you'll see in the next section, next videos, that we can stretch these things. We can move them up, down, left, right to fit patterns in data if there's repetition, if there's things that go up and down and up and down and up and down, like temperatures during the day or tides at the oceans.